Recall that in the last video, we talked about how to prove that a quadrilateral is a parallelogram. In this video, we're going to talk about how to prove that a quadrilateral are all the other types of special quadrilaterals that we've been discussing this chapter. So before we get to that, let's just review how to show or prove that a quadrilateral is a parallelogram. There were 5 ways to do this. The first way to do this is if both pairs of opposite sides are parallel, then you can say that that quadrilateral is a parallelogram. The second reason was if both pairs of opposite sides are congruent, then that's enough information to say that the quadrilateral is a parallelogram. Also, both pairs of opposite angles, if they are congruent, that's another way to prove that a quadrilateral is a parallelogram. If both of the diagonals bisect each other, that's the fourth way to prove quadrilateral is a parallelogram. And then finally, the last way to prove that a quadrilateral is a parallelogram is if one pair of opposite sides is both parallel and congruent, then it is a parallelogram. So remember that when you're doing a proof, you really only need one of the above in order to prove. So just want you to kind of make note of that. You only need one of the above to prove it's a parallelogram. Okay, you don't need all 5, you only need one. Okay, moving on. To prove that something is a trapezoid, well, the only thing that we know about a trapezoid is that one pair of opposite sides is parallel. So that's all you need in order to prove that something is a trapezoid. For an isosceles trapezoid, you would need to first know that it is a trapezoid, so it has one pair of opposite sides that's parallel. And if the non-parallel sides of that trapezoid are congruent, that's enough information to prove that it is an isosceles trapezoid. So keep in mind, you first need to prove it's a trapezoid with one pair of opposite sides being parallel, and then the non-parallel sides, if those are congruent, that's enough to prove that it's an isosceles trapezoid. Another way to prove that is if the lower or upper base angles of the trapezoid are congruent, then you can say it is an isosceles trapezoid. And finally, if the diagonals of a trapezoid are congruent, then we can call it an isosceles trapezoid. So I know this may seem a bit overwhelming because there's a lot that you have to remember, but most of these ways have to do with the characteristics of the quadrilateral. So as long as you really know those characteristics, then you should be fine with remembering these different ways to prove the shapes. So moving on to show or prove a kite, you would need 2 disjoint pairs of consecutive sides that are congruent. And again, this is just a characteristic that we already learned of the kite. The second way to prove a kite is if one of the diagonals is the perpendicular bisector of the other, then you can say it's a kite. To show or prove a rectangle, if the parallelogram contains at least one right angle, then we can categorize it as a rectangle. And notice that it says parallelogram. So first we must know that the shape is a parallelogram, and then it has at least one right angle. So we would know it's a parallelogram by one of the 5 reasons we discussed in the last section or at the top of the notes. The second way to prove a rectangle is if the diagonals of the parallelogram are congruent. And then the last way to prove rectangle is if we know that all 4 angles of the quadrilateral are right angles. So notice for this one, you don't need to prove it's a parallelogram first if you know that all 4 of the angles are right angles. Now the last 2 figures are the rhombus and the square. So to prove a rhombus, first you would need to show, for this first reason, that it's a parallelogram that has a pair of consecutive sides that are congruent. Also, if the diagonals, if they bisect 2 of the angles of a parallelogram, that's enough to prove that the quadrilateral is a rhombus. And then finally, if the diagonals are perpendicular bisectors of each other, then we can conclude that it's a rhombus. And then finally, the square, the most complex quadrilateral, you basically would just need to prove that the quadrilateral is both a rectangle and a rhombus, since that is our definition of a square. It has the characteristics of both. So you would need to first prove it's a rectangle and then prove it's a rhombus. That would be enough information to prove it's a square. Now in this section, to really test whether or not you know all these different ways to prove special quadrilaterals, you're going to see diagrams similar to the ones that I have listed below. These diagrams are labeled with tick marks. They all look like squares. But that's the point. They're actually not all squares based on the tick marks. So this is really going to test your knowledge on whether or not you know the different characteristics of all the special quadrilaterals. So make sure that you really take time this chapter, if you haven't done so already, to study the flowcharts, study all the characteristics, because there will be a section that you will see similar to this in the homework and on some of the assessments this chapter. So I'd like you to try to pause the video and see if you can look at all of the different tick marks on these diagrams, and I want you to just jot down underneath, maybe in pencil, make sure that you give the most descriptive name in your answer. So key word here is the most specific name for it, because it will be marked wrong if it is not the most specific name based on the tick marks. So go ahead and pause the video now and try these examples. Okay, so let's go over these answers. The first one would be considered a parallelogram because it has both pairs of opposite sides that are parallel, and that's one of the ways to prove a parallelogram. Number 2, the only thing we know is that it has one pair of opposite sides that's parallel, so the most descriptive name would just be a regular trapezoid. For number 3, we know the diagonals bisect each other, so that would make it a parallelogram, but we also know that the diagonals are perpendicular. So because they are perpendicular bisectors, the most descriptive name for that quadrilateral would be a rhombus. So if you put parallelogram, technically you're right, but you didn't give the most descriptive name, and that's what I'm looking for here. In number 4, it looks very similar to number 3, except notice that all the small tick marks on the diagonals are the same. So therefore, the diagonals must also be congruent. So we already know that type of shape is a rhombus, but because the diagonals are congruent, that would also make it a rectangle, and since it has the characteristics of both a rectangle and a rhombus, the most descriptive name is a square. Now, these last two, number 5 is a kite because we have two disjoint pairs of consecutive sides congruent. And number 6, we just have that both pairs of opposite sides are congruent, and that's one of the ways to prove a parallelogram. So hopefully you have a better idea of how to prove that quadrilaterals are special quadrilaterals. Please, please, please make sure that you take time to memorize all those characteristics of the special quadrilaterals. You will need to do that in order to be successful in this chapter.